think we are live again. I don't know how it stopped the live, but I explained some of the questions. Okay, anyways, now we are live. I don't know why it is disconnecting. I'm not using data and I know I'm not running it. So I explained this question. This is from I explained some of the question, and this you can see here start. I think you may be not able to. It's not visible to you. Okay. So I saw some questions and explained some concept. I saw it stuck yet. Where it stuck? It stopped at here, I think. Yeah, when I explained this question, it stopped, like inserting n square elements in AVL tree. Okay, in this with an elements initially. Okay, in this I think it gets stuck. So yeah, I'll say one more time. I mean I will not say everything. So how, like, there is one important property called log n factorial. So if you have log n factorial, like n square, like n factorial is similar to n power n. Okay, you have to remember this. So in this condition it will become log n. Okay, fine. So this is the basic rule. So you can say like it is like n power n is not equals to n factorial. Like n power n is strictly greater function than n factorial. So if you apply log, it will be equal. Okay, fine. So anyways, this is the basic concept of this question. I think I don't know, like this stopping. Am I live now? Yeah, I think it's live and everything is okay. So okay, I'm going to do this. So I told you to, I told that I will solve one question. This question is too lengthy and I don't answer. Looking for that question. This question is C programming. No, this 46. No, this 46. Yeah, this question. This question I got answer 15, but it is from C programming. So given two functions. Okay, I will zoom out it. Control minus. That's it. One. Still not visible. Still not visible. Yeah. Now it is okay. So here what they are given two functions, first function and second function. They mention static variable inside the both function. Okay, like the same variable, but they mentioned inside the function. Okay, it will alive up to this function block ends in the static area. Okay, it will in the static area. So if I'm not wrong, it will be the correct concept. So let us see. No, it will end until the whole function will end, like function 1, function 2. So what the question was, they are asking the return value of f2. Okay, f2 of 5. Okay, the only value of f1. So here if we consider f1 function 1, what they are saying was they are initializing one variable. It is of type integer and it is static variable. Okay, it is not auto or register type. Okay, so by default if we don't mention static or anything, it will be auto variable only. So okay, so in auto variable, so it will die after executing the whole block. I mean whole block in the sense, for each iteration the I will be gonna start new value. I mean I is initialized to 0 if they mentioned as 0. So that's it. If they mention static, it will maintain the whole block, and suppose this is a block, so here is a static I. Okay, it is initialized only one time. Okay, and then next it will not initialize it one more time. If we call this function n time, this value is initialized only one time. Okay, and it will keep on updating. So okay, well, static. If you don't have static here, static keyword here, and if we call this function n times, okay, so this function creates, oh no, this function initialize, no, this value is initializes n times. Okay, it means if we call this function one time, again this value is initialized to 0, second time again 0, third time again 0 0, so like that. So this first function call, the I value updated to 5 or 10, like that. So if we call this second time this function, this will be 0. So this is important of static keyword. Okay, so with this question, so how it goes. So in function 1 they are given static, okay, they are initialized to 0, and if n is greater than 0, so it is pre-incremented and it will again returns to n minus 1. So here I returns like how number of times. So if the number is 5, and it will return 5 times, so I value incremented to 5. I mean, it's not directly, it will add on. So and that's it, just count the number from the back. Okay, fine. So function 2, what is function 2? Okay, function 2, they are initialized at I equals 0. It is static variable, static keyword. So if n is greater than 0, so we are going to summing up, and we are again calling function 2. Okay, and we are returning I, that's all. So return value of 2. So they given function 2 of 5. Okay, I have done this question, I got answer 15. So let me do this question. So let me verify where I got wrong. 15 I got answer, but let me see this question. So we're calling function 5. So first one we have to initialize. So this is first function call, this is second function call. So I values, so I, okay, I value we are initializing. So first function call is 0, and here also initialized 0. Okay, fine. Both are static, right? First one, function 2, function 2. Okay, then what next? We are incrementing, okay, and we are going to pass n as 5. Incrementing, so okay, this function code, this is true, n greater than 0, it is true. And to I equals to I plus f1 of 5. Okay, here it's called f1 of 5, and we have another function, it is called f2 of, what is this? Here f of 4. Okay, here if we go like this, it will become I equals to I plus f4, and here f2 of 3. It will gonna do like this. Okay, so let us do, or we can also find these values like that, f of 3, and it will become f of 2 as f of f2 and 2 become equals to I plus f2 become f2 of 1. Okay, if it's 1, okay, if it's 1, it what if it's 1 inside the loop, and if I told like I equals to I plus f of 1, like f of f2 of n minus 1 is 0. So here if it is 0, then it will come and the loop, and it will return I value. So in this condition, what we're doing is, this is top down approach. So it is top down approach, we can say. From top onwards we have to do this. So fine. So what we have to do? I first we explain it will become pre-incremented. So I will become 1, f1, right? It will become 1. I think it's gonna be messy here. If we start like f2 of f, okay, this is f2 side, this is f1 okay, first initialize to 0 both, so so it is incremented to 1, and this function will returns up to the number 5. Here incremented to 5 directly, so it will incremented to 5, and here f2, here first initialize to 0, so it will become 5 plus 0, it will become but in F2 the static variable of 5 will become 5, okay, and then this whole become 5, so this get cancel, and here F2, here no, F2 of 4, here it become 4 times, okay, here 4, here 4 means we have to add this to 4 because it's incremented, so it become 9, okay, 9, and here I, what is I here, I is 5, okay, it become 9, so I plus, we have to add this to plus 9, become what, 14, okay, 14, this will become 14, then we are going to go, this will become what, 9 plus 3, 12, here I is what, I is 14, okay, 14 will become 26, yeah, it is 26, 6, here F2 is 12, right, that is 12, F2 means it will become 2, we have to add 2, become 14, okay, 14, and here I is 26, what is this, 26 means it will become 50, oh, crossing more values, okay, 26, what is I here, 26, okay, 26 plus 14, right, become 50, yeah, become 50, become 50, but here I equals to F is 1, so increment only one time, yes, metro segment one, so it become 15, what is the value of 50, oh, F is 1, okay, it is not, okay, it is incrementing only one time, right, so become 15, and here F1 returns as 15, and then okay, if it is in the 15, what is I, okay, am I doing anything wrong here, oh, I is 26 needs to become, no, it 26 plus 14 become 40, not 50, what become 50, 40, so okay, so here well, I think you're not able to see, okay, I think you can able to see it now, so here to become 15 plus what is 40, I has 40, okay, 40, then it will become what, will become 55, okay, so after F2 will become 0, so 0, if we encounter here 0, n is, if n is greater than 0, so it false, it will return I, so what is I here, it will return I from F2, okay, if you return I from F2, it will be 55 as final, okay, so answer 55, what it, so this question carries 2 marks, so per question, okay, fine, I think I have to take some break, I need to eat some food, and then okay, we're done. So this is what about NPTEL, you can see I got, okay, let me do this to enlarge this, enlarge to normal scale, it's not working, control plus right, oh, it is working, this not is okay, yeah, no, it is okay, so you can see I got around 19%, need to see grades, so it is not yet updated, my score is 19, okay, pair average not given, median score, like it will be updating on within next 2 days, I guess, yeah, this is my first mock test on overall, but on NPTEL, okay, fine, my stream is okay, yes, yeah, like but I'm all, but I will be back at 4 4:30. 4:30. Let me fix 4:30. 2 p.m. break. Break. Lunch break. Break. What is break? Okay, what I will play? Maybe something related to any music which is not copyrighted. I must play. Flute. I think it's not copyrighted, right? Music. Oh, they are going to shoot the thing millions 3 years ago. I think this will be copyright. So once it's 30 minutes, I will do 30 minutes. That's it. So I think it will be good. has completed 30 minutes. Yeah, the song is for 30 minutes completed. So we have solved this NPTEL questions, and then oh, I need to zoom out. Is it okay? Yeah, no, is it okay? Thank you. No, is it okay? And let's ask some few questions. And what next? Am I streaming? Yes, I think I'm streaming. It's live. Yes, it's live. So what I have to, okay, I have to update your 6. Oh, that's it is already updated. Okay. So yeah, I have to do some questions on PYQs. Git overflow. Let me solve few PYQs. I don't know which topic should choose. Okay, let me open this. Just open. Okay, why this takes so much time? Okay, Thomas Bluetooth. Okay. I know shortcut, like not short. I remember URL / and books filter. Yeah, that's all. That's it. So this PYQ. Okay. Theory and architecture. Okay, didn't check any of the question. Okay, let me do some questions. Let's see the topics. Which one is speed of memory interruption? Okay, we have handling hazards. This data dependency, cache memory. I think addressing motion cache memory is super important. 16 questions from cache memory and 90 questions from address, and then 21 questions from machine instructions. Here from virtual memory there are only 3 questions. Okay, so I have to database. Yeah, I complete database. Conflict serializability. Okay, I think we written one test, right? Database normalization, which is enough. Okay, so which one is more important? What is this? This is totally 3. Database normalization is of 56 questions are there. It is more important, and then conflict serializability one, and after joins. Okay, indexing 15 question, ER diagram 12 questions, and then okay, a relational algebra there are total 33 questions, and transaction and concurrency 27 questions. Okay, in this chapter we are going to learn, right? I guess. Okay, transaction concurrency. Okay, this 2PL protocol. Okay. Okay, transaction. Okay, fine. So this topic is also one of the important. So right now I have completed kind of like the basics of DBMS, and to do normalization and ER diagram, partial dependency. Oh, yes, is this consists of normalization or what? Okay, we have this completed. Let me solve this. Okay, consists of PCNF and TNF. I know up to enough. Okay, but I can also do this type of questions, and I total on 3 questions, but why test 1 confusing questions? Why is this? Okay, let it load. So Okay, let us solve these two questions and then later get into later stuff later. So, so what is the question number 1? It is from GATE 2026 question. Set 1. Oh. Just let PQRS be the attributes of relation regression schema. It extends to Y indicates functional dependency in the context of relation X is subject to dependency. Okay, doesn't tell the following always true. Okay. So if PQ tends to R and P tends to R, okay, it's just just checking the properties. Okay, if PQ tends to R, then P tends to R. Okay, this is and okay, and P tends to R, then Q tends to R. Okay, this is P tends to R. Okay, Q tends to R. Okay, we can't say, right? Okay, if P tends to R, then R tends to R is possible, but is not always true. And then if PQ tends to R, then P tends to R and Q tends to R. This is true. Like B is true, this is property, and P tends to R and Q. Is it MSQ or MCQ? I think it's okay there. It is MSQ, but it is for 1 mark. The heck, bro. Okay. Can't say this right here. Can't say this. Okay, I have some small dot on here. Okay, let me not fix A as answer. Okay, B and what is B is correct, and P tends to R and Q tends to S. Then PQ tends to R S. Can we combine like this? No, right? P tends to R and Q tends to S. P tends to PR, Q tends to QS. QS. Oh, we'll combine up. Okay, I think we should not combine like this. Let us see. And then if P tends to R, then PQ tends to R. Yeah, D is absolutely correct. If I'm not wrong, AD will be the answers. The heck, bro, it's not C. No, it's CD is the answer. Why not P? PQ tends to R, then P. Oh, it is R, not AND. No, it is absolutely wrong. Become PQ tends to R, then P tends to R, it is AND, not R. R means either this or that or both, so it's not true. If it is the AND in B option, then it is absolutely true. But okay, it's not true. So if P tends to R and Q tends to S, then PQ tends to RS. Okay, so I think we can also do like this. So this is true. So option C and D, that's all. So okay, anyways, but one question is done. What is the second question? Consider the database relationship with attributes. Okay, A, B, C, D, F, G. Okay, and having the following functional dependencies. A tends to be F. Okay, so okay, this is multiple select. Hang on. So let us see, like if it's A is the only candidate key of R. Okay, A is the only candidate key. Okay, like B is not there, C is not there. if we can combine with BC, okay, here candidate key can be A. Like if we do A closure, we will get all keys like A, B, C, D, A, B, C, A, B, C, E, F. Okay. If we do E, we will get D, G. Okay. If we do B, C, we will get again A. So if we got all A, B, C, D, E, F, G. Okay, A, B, C, D, E, F, G. Oh yeah, we got all. So A is the one candidate key. But what they're saying A is the only candidate key. So let us check BC. Yeah, BC can give A. So if we get A, we get everything. So BC is also a candidate key. What is this third option? E are the candidate keys of R. A comma BC comma E. What is E? If we do E, we get what? We get E D G. E D G. What is E D G? There's nothing. E D G is nothing. So option B will be the one correct answer. So after relation R is not in boycott normal form. BCN. So how do we check it? First we have to check 1.5 and 2.5. I think so. So like me. So is it in 1.5? I think we have to divide this table into A tends to B. Oh, getting larger. A tends to C. A tends to E. A tends to F. And E tends to D. And E tends to G. BC tends to A. Okay. This is the whole table. Yeah, it is in first enough. I mean, 1.5. We have to check 2.5. Like, is it any partially dependent or not? Okay. So single keys partial. Okay, they are repeated can be, but it tends to E, it tends to F. It is F, it is not E, it is F. Okay. Yeah, so what? in place of, okay, in place of B, we can write it as A as well. Okay, it has to be with AC. So that's it. If this is whole key, this part, right, we can get this. So this is, we can get from this, we can get this one like subset of this key. We can derive this key. So you can see here, this is partially dependent. So it is not into enough. So if it is not into enough, it is not in 3NF and BCNF and then also higher of any normal form. So how this nomination works? First of all, I will say one simple. If my answer is right, let me say one simple logic. Or I think B and D. D also correct. Yeah, it is not in BC. Yeah, it is correct. So B and D are correct. It is not in BCNF. So let me say my logic. So how I do like these questions. First, this is 1 enough. Okay. And this is 2 enough. And this is 3 enough. And 3 enough, like just modification is called BCNF. Let's imagine this is BCNF and this is 4 enough. There are n number of numbers. Okay. And then if a relation fails here, we don't need to check above relation. It will fail. Okay. If the relation fails in here, we don't need to above. We don't check above. That's all. So that's it. So here we found in 2NF there are partially dependent keys are there. So that's fine. It's not in 2NF, so it should not be any other normal forms as well. So 1NF. It is true. So I think B is the answer. So yes, it is 2025 DA question. Oh. Well, so done. This question I marked. So I need to remember that if there is P tends to R, so Q, PQ. If P closer tends to PR, Q closer tends to QS, then PQ tends to PQRS, right? If we can also combine like this. Okay, got to know this function. What is this? Let me see this. So okay, we completed 2 questions, right? Okay, 1 question, 2 questions. Will let this be a separate, and What is consider relation schema? Okay, team. Okay, get this schema. This team name city owner. Okay, the one city with functional dependencies name city name to city and name to owner. Okay, fine. So it is in one enough. So the relation team is decomposed into two relations. Okay, T1, okay, name city, and T2 name owner. Okay, which of the following is true? Name city name owner. Okay, the relationship is not in BCNF. Okay, the relation T1 and T2 are in BCNF. The decomposition what is it? Consisted lossless join. The relationship team is not in 3NF. Oh, they're going exceeding what? I don't know about lossless join or not. Okay, let me see. So they are decomposing these two tables, this name city. Okay, if we do like name and city, it will become okay, name and city and name and owner. Okay, that's it. So what we are going to get? This is not into enough. I think if my correct will be like B and C the correct answer. But I don't know how to solve this. Yeah, B and C are correct. So if we do closure of the city, we'll get only city. To name, there is a partial dependent on this. Why? Because they are not given anything. So let's see this question and what is lossless join from this solution. So yeah, it is correct, but I need to repeat it again. So let's get done. Let's get done. I mean, let's get wrong. Okay, I will do that again. Or can I write it again? Okay, not do it again. Do it again. It. Done. Okay, done. This is not saved. Okay, so let us solve. Okay. I think I solved this question 1 week ago. That's great. So what's this? Oh, property of correct brains. Okay, property of is cooperated for correctness. Okay. What is lossless join? See here, a relation with only two attributes is always BCNF. Okay, so both one T1 is attribute name is key and why it is that's why. Okay, why is lossless join decomposition, lossless join? Both and okay, see here. Both T1 and T2 has common attribute name and it is key in T1 and T2. That's why the decomposition. Okay, this is common attribute. What is this? T1 and T2 has common attribute. If cannot represent, then it is lossless join decomposition or what? Well, let us see the best answer. Oh, this is the best answer for this question. I think here there are some kind of answers. We got 9 of 4. So let's see. LHS of each FT is a super key. Yeah. Therefore, team is in BCNF. Okay, LHS is super key. Yeah, it is. Okay, we have to assume. So because super key, like it should not present any null values. That's all. Every BCNF relation is in 3NF. Okay. T1 name to TNF. Functional dependency name city is BCNF. T2 name owner as FT. Name owner is in BCNF. Both T1 and T2 has common attribute name and is key, and T1 and T2 hence the common. Okay, how is both T1 and T2 has common attribute name and is key and is a key. Okay, in T1 and T2 hence it. Okay, suppose there is a common attribute between two tuples, I mean two relations. Okay, lossless join. Okay, lossless join means what? Lose, not lose, lossless, lossless, not lossless. Okay, lossless join means it should be common attribute between two relations we call as tables, and it should be common attribute and it should be the key. I think it will be the more simple. Okay, decomposition of the lossless. Let me search with CLAD. Okay, I'm getting wrong. Where is this? Technical tab I got. Okay, let me search for new. Showing so. Okay, the precision. So to define lossless, decomposition, what it is, join or what? Decomposition. Okay, decomposition. The relation common attribute must be a key, must be a super key. I think I need to set medium, not high. Efforts should be on medium. Okay. Is this the correct way? Is this the correct way to get it? To check. Okay, to check it. To check. Okay, let me switch what it will say. Meanwhile, I'll go to this and hence decomposition includes as so from BNC. Yeah. So okay, I'm done with these questions. So what next? Indexing and commented joins, multi-valued, okay, natural okay, no query, integrity, no relational SQL, no SQL, super key. Okay, let me do what is super key here. What is super key? Oh man, there's no super key. So let us solve this super key. Will you consider a relational database? I think like yeah, but it's very poor in condition. Don't know when it breaks. Let's see. Okay, where is this question? So super key. Consider a relation database schema with a relation not okay. Given relation ABCD work if AB and AC are the two candidate keys. Okay, let's assume AB and AC are two candidate keys of the relation or the number of super keys of the relation are is. Okay, there are totally 4. The number of super keys. Okay, every combination of your candidate key is also relational. So let us think these two values must be fixed. Okay, these two values must be fixed and we have to just change these two. So if it is AB, then how many choices we have? We have just CD and DC. Is it? It should be 1 into 2 plus 1 into 3 should be 4. 4. If I not wrong, it would be 4. I think so. It would be 4. Oh, what? 6. how 6 BC okay, it is AB and it is C and D. If it is D, okay, if here C is okay. Array, wait, let me do this again. If in this it can be C or D, it has two choices, and C it has two choices. Okay, 2 into 2, it will become 4. Okay, each one contains 4. Okay, and we have also what candidate key segments AC, which is fixed. And this also contain here B and C, so contain 4, 8, total 8. So if we see, so how can we get then? Can we get it? It in shuffling nature? No. This can be free, but 4. It's more. GATE 26 set 1. So it's the good question, I guess. GATE might be. What this is? NPTEL question. This is 2 mock question. I need to take care of this question. Okay, CB. Wait. What if the order changes? If BC is same as ABC, yes, it should be same, right? So we don't need to take about any order. So yeah. So we don't need to take. So for example, this is 4. Here, ABC space. Feed 2 fix, and what is there here? B and C. Okay. In these 2, what it has? It has 2 choices. It has 2 choices. Okay. In these 2, what we are going to get? We are going to get one common. I mean, one means we're going to get A, B, C, D as 1 as twice. It is duplicated, so we have to remove this one and minus 1. That's it. That's all. And what's one more one? What is one more? What is that? So I need to check the solution as well. The basic concepts, there are it is n equals to 4, candidate keys a minimal number of sets that uniquely identifiable in a supposed. Okay, so they're given just that formula. So the number of super keys contains candidate keys to pop. Okay, to port. Okay. So number of common super keys candidate keys 2. Okay, how to find common super keys? What is a common super key? Okay, we write like A, B, C and A, B, D. A, B, C, D and A, B, D, C. Okay, these are the first set of consider A, B. So consider A, C, B, D and A, C, B, A, C, D. Okay, A, C, B, D, A, C, D, B. Okay, these are the keys which we got. So then what? So what is the common between? If we miss the order, so I think we have to cancel this out. This is one time repeated. So how this is total number of keys are super keys from candidate key of AB plus super key of candidate key of CB. AC minus common super key. Okay, it is common super key. Right? Super key means AB as super key and AC as super key. Getting it properly. Okay. Okay, therefore inclusion actions. Okay. Okay, define the number of super key formulation, or you can candidate keys CB and AC. We use principle of inclusion exclusion. Okay, like got it. So there are some candidates which are both. Basic concept relation are contain 4 attributes. Okay, A, B, C, D. Percent equals to 4. Candidate key CK, a minimal set of attributes that uniquely identify tuple in a superset. Candidate key is super key. Okay, fine. Formula is to find if a candidate key has k attributes. Okay, the number of super keys of relations with n is 2 power n minus 1. I mean 2 power n minus k. So how I am doing is there are 2 super keys, right? If these 2 fix, so it will become two choices. So I'm also doing the same, but they are giving in formula. I am doing just in normal way. So okay, so to power minus catalyst step, let us be a super key containing AB. Okay, so AB should not be right. Shall we rearrange? Wait. Here it can be also AB, right? It can be AB, it can be AC as well. Yes, now got it. So yes, I got it. So we can remove these 2 and these 2. That's it. Here this is unique and this is unique. It's alright. I think so, and this was the correct approach. Do what next calculation? So step 1, super key is counting. Okay, the candidate key AB has 2 attributes, so remaining 2 attributes are number of super keys containing AB. The candidate keys has 2 attributes, so remaining. Okay, so how is that doing? Okay, S1. So they're just using the formula and figuring it out. Super containing AC. So okay, so common super key. Okay, so okay, the both candidates common super keys. Okay, here common super key can be let me not cancel out all terms. Common super key. Okay, let me check question. Okay, I got to go. But this question, that was okay, and I understood the inclusion exclusion principle, but or 4 months, whatever it is, the union of F3 has 3 attributes and the remaining attributes T. As intersection of Leetland superkeys and so the superkey that contain both AB. Okay, let us see this question. Let us technically see this question, is very important. So yeah, anyways, I have to go. I just solved the question. This is third question. Okay, this is fourth question, I guess. Yeah, like today